Thank you very much. Very interesting. You didn't mention anything about movement of water, drinking water from the north to the south, and whether, because I know there has been a lot of discussion about that, and a lot of people saying it will never work, and other people saying it would work, and people
Yeah,
saying it could be used for navigation, and other people say no, let's bung it in a pipe. And there's it's not CRT, but there's a long wanted link in the East Anglian waterways to
yes.
stop people having to go across the wash.
So
And
briefly to answer that, yes, there's already water transfers that we do for public water supply. So the Llangollen Canal transfers up to 83 million litres of water, of which some goes to United Utilities. The Gloucester and Sharpness Canal already transfers up to 245 million litres a day for Bristol Water, and it already contributes about half of Bristol Water's drinking water supply. And a lot of people don't know that. And the Trust earns several £1 million a year for doing that transfer. But those are existing schemes that have been around for a generation or more, in some cases much longer. What we're looking at right now is the future pressures on public water supply are very intense. This summer has shown, and it's certainly got the Minister and the Secretary of State and the regulators quite spooked by just how low the water companies' resources have become this year. And nobody would want to experience standpipes in the street and water rationing like we saw in the 1975-76 drought. I was only 2 at the time, so I can't really remember it. But no government wants to be in charge when that happens, if that happens. But with climate change and a growing population and pressure on water, that there's a real risk it could happen. So government's really keen for much more investment, and the canals can play a part in that solution. So water companies have been tasked to increase their resilience. They've come up with 20 major significant investment schemes, what they call strategic resource options, and they are working through the design and the feasibility of those 20 schemes. 19 of them are basically water company schemes: new reservoirs, desalination, water company to water company sharing or moving of resources. One of the schemes is a canal transfer that would bring up to 115 million litres of water per day from Minworth, so near Birmingham, down through the canal system, down the Grand Union, and down towards London, although not all the way to London. And it's one of the preferred schemes, and it is going through the process of getting approvals. And in theory, if it all gets signed off in the next few months, it could move towards detailed design with the water flowing as soon as 2030, which in the grand scheme of things is a major UK infrastructure project. Only 8 years away is very soon to actually see a water transfer. So that would involve, I think, over £180 million of capital investment in our infrastructure. So more back pumping on the uphill legs, more upgrades to locks and bypass and bywash structures on the downhill sections, more bank reinforcement, and changes to low spots on towpaths to allow that water to convey through the system. So a huge amount of work potentially to do in the next 8 years before London starts to see that water flowing from the Midlands, basically. So it can happen, and hopefully will happen.
Great, thanks for that. I'm just thinking it's difficult enough to get into the locks, the narrow locks on the Llangollen with the bywashes. It's going to be really interesting trying to get 2 boats to go in at the same time when all this water's gushing out. But hey, let that be a challenge for boaters everywhere. There's a few questions people have asked. Just run through them quickly. Will your very informative slides be available for download after the meeting?
Yeah, no problem at all. I can share them with you, Roger, and we can put them into a PDF or something. I'm not sure how I can embed the videos. You might not be able to get the videos, but all the other slides, there's no problem with sharing those.
I'm sure you can stick a link in it just so somebody could go online and download that one. The next one is very impressive presentation. CRT. I better not be too nice to CRT, haven't I? It's like it was an okay presentation. CRT sort of seem to know what they're doing. How would you sell the benefits of your water management to the boating community?
I'd like to think we as a team are making a difference. I think we're not the only part of the jigsaw. We've got volunteer lock keepers, we've got boaters themselves, we've got local operational teams, and we've got Neil's sort of engineering, sort of civil engineering teams that together are trying to do, to get the water balance right, not too much, not too little, meet those future challenges, and prolong the available water when we are faced with these challenges, because I think without the work we're doing, we would be in a lot worse position. I think just taking the water abstraction licenses, the sheer effort we've had to put into securing our water resources for the next generation is very considerable. It's quite an unseen piece of work behind the scenes, and it's the same with our reservoir projects and the reservoir work. A lot of boaters and users of the network don't realise where the water comes from, and sometimes take it for granted. And if we can use these opportunities to showcase there is a bit of science behind it, there is a bit of effort that goes into managing water. And yes, we're not perfect and still room for improvement, but it's a continual process.
The next question, you mentioned the importance of discharge into the canals to help with water resources. How does CRT monitor the quality of this water that is introduced into the canal system? Now, that's a pretty topical.
It is, especially with I think one of the water companies recently being fined, I think £90 million for one of their polluting discharges. And the water companies are coming in for quite a rough ride from the regulators and government about not doing enough to protect natural water bodies and streams and rivers and make sure that they're not causing harm. So we rely heavily on the Environment Agency because they will permit and authorise the water quality parameters. They will make sure there's monitoring in place by that organisation doing the discharge. So it's usually a water company, but not always. Sometimes it could be an industrial process, an effluent that's allowed to discharge, but it'll be strictly controlled by the Environment Agency. And where we do accept these discharges, we will have commercial agreements, and the terms of the commercial agreement will also ensure that the organisation doing the discharge will have to comply with any terms of any environmental permit or discharge consent that they're issued by the Environment Agency. We've got the right to say no to most discharges. If we don't like it, we don't have to accept it. The only exception to that is for highways runoff. So drainage highways authorities do have a permission to discharge to watercourses, including canals, but they have to compensate us if they cause any loss or damage. So we do still have some means of recourse if they're causing us problems.
I mean, one discharge that's quite topical in London is Pims Brook on the River Lee.
Yeah.
Where often things of a nasty substance go. How do you find this is being recorded, so how can you answer that? Working with the Environment Agency, because they are somewhat short-staffed.
Yeah, I think it's a real sort of collaborative effort. It's working with the water company quite often, and they've got the funding and they've got these major investment plans to improve some of the issues that come from their operations. It's working with the EA. And other catchment partners as well. Sometimes it's local communities and local authorities who have got a role to play to try and ensure that water quality. But it's not as easy. And I know the Pims Brook for many years has been a real problem hotspot with the water quality issues there.
Quickly nipping for who is the Minister of Water that you mentioned?
So the Secretary of State is Therese Coffey now.
Or should we say today?
Yes.
Because it might be different tomorrow.
Yeah.
So that is Ms. Coffey, no longer Deputy Prime Minister, of course.
No, she's now Secretary. I'm fairly sure you're right. It's hard to keep up with it, but I think that's her current role. She's been reappointed. She was overseeing things for us previously, and then moved to a different role. Now she's back again.
When abstractions are considered, why is no allowance given for water that is later returned? Most water is only borrowed. Not like water taken for industrial purposes, agriculture, car washing, etc.
Really good question. So the way the water balances work and the way the Environment Agency look at our abstractions is at the point where we're taking it from a river or stream, it probably isn't going to return to exactly the same point. So it will return somewhere else. It will return downstream. It might find its way through its leakage and seepage back into groundwater. It might get taken into a reservoir in the winter months, and then we release it into the canal in the summer months, and eventually it finds its way back into the catchment. So it's that disconnect in terms of space and time that means that it's seen as a sort of consumptive abstraction. But in some cases, with say a hydropower scheme, the water is much easier to say that the water's taken in through a turbine and straight back out again and returns to the water course. So those are seen as non-consumptive. And we The good news is that a lot of our abstractions are charged. The charging rate that the Environment Agency levies on us is zero, because it's seen as a very low risk abstraction that we undertake. So unlike an industrial use or for public water supply, where there's annual charges, we don't have to pay an annual fee for the water that we're going to be taking through these licenses.
Which leads on to a question, another one that says the North-South water transfer project you talked about, will it or could it represent a significant income for Canal and Rivers Trust?
Yeah,
well, you wouldn't be doing it otherwise.
We wouldn't be doing it otherwise. Yeah, well, there are some positive benefits that, aside from the money. So for government, we want to, particularly as we come through our government grant review, and those who know how the trust is funded, we've got a 15-year contract with government. We're in year 10. We're renegotiating at the moment, and government have got real concern about water security, and anything that we can do that portrays the trust in a better light. And that video sort of perhaps highlighted, how the trust can be providing solutions for all kinds of things. Then yes, that's always going to be good for the politicians to see that it's more than boating. Boating is so important. It's more than ecology and well-being. It's actually keeping the taps flowing in London, for example, which is a pretty big thing these days. So there's a lot of kudos that comes from it, but also the commercial income will be will make sure we get a good deal as well.
Just a last one, which I'm sure you answered with one of your graphs. Somebody wants to know how much water is drawn from Chasewater Reservoir. And looking at all those graphs, I think in a couple of days you could probably focus in and find the exact amount per day.
So the short, I think there's probably a subtext to that question. So Chasewater Reservoir is one of the few reservoirs on our network that we don't actually own. So in 1957, our predecessors sold, effectively, or handed over the ownership of Chasewater Reservoir and the dam to the local authority at the time, but we retained the rights to the water, and we've been generally okay at accessing that water for many, many years. But in the last couple of years, we've had a few challenges with the owner, which is Staffordshire County Council, and we've tried to work as collaboratively as possible to iron out there's differences of opinion. The reservoir itself is a SSSI, so it's a site of special scientific interest. So we can't just access the water and draw down the reservoir because it could cause environmental harm. So we're trying to work through that problem. So in the last couple of years, we haven't used the reservoir for canal supply. And it's remained pretty full, but the long-term plans are, of course, to maximise use of all our different water sources, because they're so critical for the reliability of the canal network.
And where is Chasewater, for those that don't know?
Yeah, so Chasewater is near Wolverhampton. It's very close to the M6 toll road, and it feeds into one of the highest points of the canal network. So it goes into the Worley and Essington Canal, and then finds its way into sort of the Birmingham Canal navigations, which obviously radiate out in various different directions.
You'll be interested to know, I had a long conversation with someone up that way, I won't say the name of the boat club, who were not very happy with CRT because they said, well, they never let enough water out of Chasewater. And I mentioned it to someone and says that's because it's not ours. So I think there was a lack of perhaps understanding. I must admit, the worst canal that I've been on was the Rushall, where I didn't think we were actually going to get through. And so I set the dog and my wife off and said, well, if there's anything goes wrong, I've got enough beer on the boat to keep me going. But I think that's probably taken the conversation down a little bit now. So if Neil's still awake, are you still there? Or have you decided to get your Ovaltine out?
No, I'm still here.
Do we go? Should we go with Neil Owen, who is the Regional Engineer South, I think. Is that your correct title? Doesn't sound very exciting. Right. Oh, he stopped talking because he's only not multitasking.
I'm just in the process of sharing.
There you go. I knew exactly what you were about to do. Anyway, over to you.
Right, thank you very much. I'm Neil Owen. I'm, as I say, Regional Engineer for South. So I look after the asset engineering teams in London and South East, Wales and South West, and East Midlands. So sort of come around the bottom end of the network. So managed about a third of the network in terms of assets and kilometres of canal. Similar to Adam, I've been with the Trust about just over 20 years, and I also did a period with the Environment Agency. Different teams, but gives a different, perhaps a little bit of perspective on things. So I'm just going to talk about firstly, our inspection process and how we sort of identify defects and how that feeds into our delivery program. Also talk a little bit about asset modeling, which we've used extensively in the discussions with government and in the presentation of the requirements going forward for investment in our assets. Prioritisation, and if I get time at the end, I'll keep an eye on the clock. Also talk about the lock gate challenge we've got. So inspection is really a key task for my team, and it's all about the data we've got. The data is used for all sorts of things, including our key performance indicators with government. So that impacts on our grant. And we have 3 levels of inspection. So we have safety and service inspection, general inspections, and also principal inspections. And as you'd expect, we've got a mandatory standard that we work to. So we've got a document and that's reviewed. The current version was reviewed in 2021, and it will probably be up for review again very shortly. So just to keep it refreshed and keep it current, and also feedback from the teams in terms of what's working, and how the inspection process actually works. So safety and service inspection is also known as length inspection. This year we're doing about 3,400 nationally. They're undertaken by asset inspectors who are trained and certified to undertake the inspections. We do it on a risk basis, so the majority of the network's done every other month, but we do higher risks monthly, and also some of the structure. So for instance, offside assets we can only get to. So the example on the bottom there, we are on the offside. To get there we need a boat, or we've got to go all the way around. We do those every other walk, so every 4 months. So in total we do 6 inspections per year, inclusive of 2 attribute walks where we look at the condition of the towpath. So we do towpath in summer, and then we look at the waterway walls in winter, because we often can't see those with vegetation growth in the summer. We do 1/8 of the network every year. Our general inspections, again, are risk-based. We do them between 1 and 4 years. We do them on an asset basis. They're done by local engineers. They really are a key visual inspection for us. So it's a chance to go out, look at the assets, go out with the asset inspectors. And, you know, some of them aren't all that easy to get to. So you can see in the bottom left-hand side, some of the embankments and cuttings we're going to. The vegetation can be an issue, and we're spending a lot of money in coming years, including this year, in getting on a handle on the vegetation on our embankments and our cuttings. Not to the extent that Network Rail have in terms of their, I won't call it a napalm principle, but certainly zero tolerance principle. And they've cleared all the trees off their embankments. Vegetation's cut to you know, Bowling Green standard almost. But we're trying to get to a point where we can see and we can get to everything we need to get to. For my team, it's really important, these inspections, because they get to understand the connectivity on the patch, and also, you know, that feel for the assets and how they're performing. And one of the things we're doing more recently is we're feeding the data from these inspections, which are done electronically, all our inspections are done electronically, back into our asset modeling, which I'll talk about a little bit more later, which starts to sort of close the cycle in terms of improved asset data. That then feeds into our modeling data, which outputs then feed into our interventions. And principal inspections. So we've got just under 300 this year, just being undertaken by the regional teams. There's more being done by the national teams. But again, undertaken by certified inspectors, normally engineers, not quite often chartered engineers. But they're based on the asset type, the condition, and the consequence of failure. So they're anything between 6 and 24 years. And there's an example there of the matrix that gives you an idea of, so the conditions are A to E, A being new, E being at the end of the service, and the consequence of failures, which is the 1 to 5 numbers. 1 would be a rural canal with no impact. 5 would be affects a mainline railway or directly affects properties. But those are also being used to generate what we're calling a health score, which is the score that's generated by models. So rather than saying it's an A to E, the health score is it 90 or is it 91? And it gives us an idea of degradation. It gives us a lot more granularity, because those bands, those D&E bands, are quite wide. And that allows us to focus a little bit more and also understand how the structure is degrading over time, because it could be a degrade asset for more. I've done inspections of assets that were done 15 years ago and were D 15 years ago and still D now, and probably will still be in 30 years time, but they will have changed in that time, and it just gives us that wider knowledge of how those assets are behaving. So some examples there of the sort of things we're doing. We've had some volunteers working with us, so looking at actually measuring cracks, recording the width, so we get that, again, that trend data, so we understand, is it something that's moving over time or is it a seasonal variation? And we're trying to make use of the stoppages. So there's an example there where we dewatered one of our bridges. We've taken the opportunity to go in and take a look, see what's going on, and also with our lock inspections. So when the construction teams and the colleagues in our direct services teams are working on the locks, we do take the opportunity to go in and do a more detailed inspection, tactile inspection. We'll get up against the walls, start measuring depth of joints and hammer tapping the wall, so we can understand if there's any hollow sections, any delamination on the lock walls. So asset modelling, well, what is it? Well, our model takes two parts. So we've got what we call a health score model, which gives us that 1 to 100 condition index. Those are the condition scores for each asset are also banded into an A to E. So for instance, it might not be the case, but 0 to 20 is an A, 20 to 40 is a B. But it varies for each asset. And the reason we've done that is because all our reporting to DEFRA is based on A to E grades. So it gives us a direct correlation between the two. But it also gives us that ability to predict future conditions. So our models include degradation curves, which is an industry standard curve, but we set that based on the expected life expectancy of a lock, of a structure rather. So for instance, a lock gate will typically last up to 25 years, but if it's a hardwood gate or if it's a steel gate, it will last longer. So we can adjust the length of that degradation curve depending on what we're looking at. Whereas a bridge could last 150 years, 200 years with intervention. So they vary from structure to structure, and also we can change the speed at which the curve operates depending on what we're looking at. So we can have a normal, a faster curve. It also predicts probability of failure. So some clever maths in there that allows us to look at what the probability of failure of that and likelihood of failure against other assets. So we compare like for like. And also what we call criticality. So that's comparing the significance of the asset to the business. So that would include things like the usage of the canal, the impact on other, so for instance, is it on a water transfer length, what the downstream impacts are. Whereas previously, we've always just looked at consequence of failure, which is just literally what the consequence, if that water was to escape, what would the impact be? So criticality is much wider than that. And the second element is an intervention model that allows us to look at what the cost, using different investment strategies, what is the cost, but also what is the impact on the condition of the structures. And we can compare across different asset types. So we can look at bridges, locks, and you can start to compare, okay, if I invest that money, what's the impact of that investment? So there's some examples here just to show what the model produces. So this gives you an example of the condition at the assessment date. So those assessments are the date the inspection was done. So that could be any time in the last 26 years based on the frequency of the inspection. But then that's brought up to date to 2022. And you can see there's a movement towards poorer condition, and the consequence, they're moving across to the effectively to right. And then on the end there, you've also got the health criticality in 10 years time, or in this case 2031, which again gives us that movement across the entire spectrum. The other option it gives us is this is looking at the intervention. So top left is as it is now. Top right is without any investment. So the curve, the trend is very similar, but it starts to move in terms of years. If we put a desirable level of income, so that's if you like a figure that we define, what impact does that have? And that, as you can see, reduces the general condition. If you've got an unconstrained condition, which effectively is, if I do everything I need to do, where does that leave me? You've got a business constraint, budget constrained, so probably less than desirable. And then you've got a risk constraint, so that is to manage the risk the same as it is today. So if we accept our profile as it is today, our risk profile in terms of Ds and Es, 4 and 5 consequence, higher consequences, then that gives us another investment level. So another option, if you like. So that moves us on to our delivery program. So we are now moving. We've previously had multiple delivery processes, and we're moving to a system where we have one program. But it has multiple elements. So we have core projects, which is our spend on assets that are not included in any of the subsets. So reservoir investment, as Adam described, Toddbrook alone is £15 million, but there is the reservoir industry has moved, and Toddbrook has probably influenced that. And we are spending money on reservoirs based on current guidance to manage the risk on those reservoirs. And that's a long-term investment program over the next 7 to 8 years. And then there'll be maintenance on that once that program is finished. We've also got a high-risk asset program, which is high consequence failure, poor condition. It's a subset that we've agreed with government, agreed with the trustees, that we will reduce those high-risk assets over an investment period. MICA, M&E, ICA, so information control, automation, there's a separate budget allocated to that M&E equipment. And there's a ring-fence budget for dredging. So circus spend is about 70 million a year, varies from year to year, and will obviously be influenced by ultimately our grant submission, grant agreement in 5 years' time. But that's the current predicted expenditure. And within that, we have what we call priority projects, which are larger standalone projects, typically high value, high complexity, higher risk. So an example there, Dead Dog Basin refurbishment, Camden, looking at £500,000 there to refurbish the bridge. The deck is actually new, so the majority of that cost is in dealing with a listed, 2 listed parapets and the brickwork repairs that are necessary to the structure, whilst accommodating traffic going in underneath. Woodhall and Hewlett are working within the basin behind that, which is privately owned. So we are maintaining that, trying to maintain that access between our works as well, and obviously in a high footfall area. The core projects make up about £20 million worth of the programme, varies from year to year. I think next year we're looking at 16 million. And those projects vary dramatically in cost. So, for instance, a lot of the controlling, a lot of the aspects here are to do with the access arrangements to the site and how easy it is for us to get plant and equipment to site. So whereas we might replace a bridge on a canal, it could be double the cost on a public highway because of the size of the kit we've got to get into site and the restrictions on getting that equipment to site, which might mean that, for instance, we have to fill the canal in to bring the access in along the canal, or dewater the canal and put access in. So in some of our jobs, the access can actually cost us as much as the work itself. The second element we have is priority works, which is typically lower complexity, lower cost. lower risk. So these are the jobs that we normally deliver ourselves through our direct services team. So in B22 within the southern region, we've got 62 packages in total for the region, and £7 million, approximately £7 million to spend. And the sort of jobs we're looking at there are bank protection, bridge repairs, such as the example there of parapet rebuild, gate replacements and gate repairs. So when we're starting to put this plan together, to put this into context, we have currently nearly 10,500 defect reports within our system. So that's our individual items within our system that record issues with a structure. There's circa 1,800 of those are allocated to directly to the asset management team, and 20% are due to be completed by the end of 23. So putting that into perspective, what I just said, we're delivering 62 packages this year within the south, and that package could be one to multiple in notifications, but typically you're probably looking at 200 notifications a year. So we're not clearing that figure, and the value is about £20 million nationally. Within the south, I'd say it's 7 million. So the question is what to deliver. So each of our notifications of defect reports have got a ranking score on them. It's based on a seriousness and urgency. So it's a 10 by 10 grid. So for instance, looking at seriousness, a 10 would be prevent use of the asset. So effectively asset is, it can't be used, navigation is closed. And then we've got an urgency rating. So urgency 10 would be that's going to happen pretty much immediately within 3 months. So we rank each of those, and then effectively we're working down a list, prioritized list. There's also, we have a cost estimate. Typically that's an engineering cost estimate initially, but we're developing costing tools to help us improve that. What we should be delivered to meet our standards and reduce risk. So we obviously have other standards we're working to, things like navigation standards. So if something is failing to meet our navigation standards, then that's a priority. And also we're looking at waterway priorities in terms of where the local teams are having issues. So for instance, they're running water regularly on a lot flight every morning. So if by intervening, we can free that time up for them to spend more productively elsewhere. And the logic applied with this is that the teams, our own teams, direct service teams, are fully utilised. They've got meaningful work to do, and it's deliverable for them to do it. We have an element of contract within this programme as well, but the majority is based on effectively using the staff we have and their skills in order to meet those priorities that we set out above. So the Lockgate programme is one of the big aspects that feeds into our plans. So sort of factors we're considering are the Lockgate model and condition. So again, we've got a model for Lockgates, and that gives us some information in terms of the degradation of those gates. Stockage protocols in terms of what we can do when. Production capacity. Our repair yard has a limited capacity. We can go outside to the external market, but we have to feed that in over a period of years. We can't go to a supplier that in a year and say, can we have 10 gates 1 year and none the next, because they need to ramp up to do that. And the requirement for consent. So for instance, some areas that are main river, we have to apply for a flood risk activity permit from the Environment Agency. Some of those can take a long time to obtain. And we have to factor into that the average stoppage cost is between £150,000 and £200,000. So that's including lock gates. So when we talk about lock gates, we talk about lock gate leaves. So on a wide lock, you've got a double top and bottom end. So you've got 4 leaves of locks, lock gates on that, plus the lifting equipment, which again can be expensive depending on the access and whether we can get waterborne equipment that's capable of lifting the gates. So for instance, this year we've been doing a stoppage on River Severn. We've had to put trackway in to get the crane in. the majority of cost, a big element of cost on that particular stoppage, because we are literally just refurbishing the gates, has been getting to site and getting the craneage there to allow us to lift the gates. And just example there of the lock model. The blue lines are the desirable level, based on a 5% increase in capacity in our repair yard. The orange leaves are what is being asked for within the model. So you can see there's a bow wave, as we call it, coming up in terms of the number of lock gates we need to replace is increasing. And what we're trying to do is balance that by bringing gates forward, and those the lines are illustrating what's happening to condition grade. So the yellow, or the orange yellow colour, is our poor condition gates, worst condition gates. The greyish line here is our D-grade condition grade rates, and then there's combined line here. So you can see that there is a creep up in condition grade over time, which then drops off again as we start to replace the gates. So just got a couple of minutes left. I'll just talk about our lock gate challenge. We've got 3,100 gates rather, about 5,800 leaves on those gates. Our repair yard currently has capacity of about 140 gates per year, but as I say, you can outsource additional leaves, and we are ramping up production within our repair yard. But just looking at that, if an average gate's got a 25-year lifespan, at that rate, we're only replacing them every 42 years. So, and sometimes we're not getting it. We acknowledge that we don't always get it right. We are doing gap-specific inspections on our lock gates, but we do get failures. And there's some examples here of where we've had gate failures. A very typical issue here, where you've got the cutaway to take the gate collars. It's introducing a weakness into the timber, and you get these cracks appearing. And normally those gates will stay put, and it will be a factor. It'll get a nudge, we get high water levels, and that causes a failure. And what we're increasingly finding is, whilst the external timber is actually in quite good condition, the core timber is deteriorating. So when we go along this and looking at it externally and sort of trying to push a screwdriver into it, it looks okay, but the actual timber inside is actually in really poor condition. We've developed temporary solutions. So this is what we call a Forceheal. So you can see here where the heel of the gate's deteriorated, and we fit this steel fabrication, which replaces the original timber, and that will increase the life of the gate. It is also something that we can fabricate these very quickly, and we always keep them. When we take an old gate out, we always keep these. So we've got them available. We have done proactive exchanges on gates to increase the life. It's quicker than you trying to fabricate a new gate, obviously, and reduces the time that we're closed. So quite a positive preventative measure if we intervene before it fails. We're also looking at new technology. So this is an example where we've looked at what other organisations are using, and certainly talking to the electricity supply companies. They have lots of poles, as do telecoms, and they were using this tool where it's called a resistor graph. It's a drill that applies a consistent pressure, and then it records the resistance to the pressure. So as you drill through, you get a profile, and you can see if you've got a soft spot within the timber. So it gives us the information within seconds, and each one of our lock gate inspectors now has one of these that they're utilising as part of their lock gate inspection to inform us where we've got issues, so we can intervene and install for example, those temporary Forceheals, in order to prevent these problems happening in the future. But we're also looking at, can we innovate? So there's some few factors here in terms of innovation, appearance of locks. If they're listed, we probably can't innovate if they're within curtilage of a listed structure again, but there will be a lot of locks that aren't listed, that aren't within conservation areas, etc., where we can look at doing something different. Certainly where we've got existing composite gates, we can look to replace those. And we're looking at alternative materials, working methods, trying to increase life expectancy and also reduce intervention. So for instance, we design the gates so that they've got serviceable parts that we can replace without stoppage. One of the things we found from this is actually the design, the impact loading on the gates is much higher than the actual water loading pressures. And when we started looking across, for instance, in Europe, the Netherlands are using what they call FRP, fibre reinforced polymers, plastics. They don't like us using that word, but effectively it's a form of plastic. But those gates have got a large steel beam that they put across once the gates are closed to prevent the ships. Bear in mind, these are big ships, but they are professional crews, from hitting the gates and causing any damage. And as I say, we looked at sort of those elements of the heads and heels of the gates and the seals, so we minimise those stoppages, so we can do things much quicker. We don't have to close the canal to do it. Lots of options. So there's the examples here of things that have been done with steel gates. These ones are on Monmouthshire and Brecon Canal in a section going into Newport, where these gates have been installed. Actually, they've been put in sections because the access is very poor. Less of a issue for us because we've got to get the old gates out, whereas here didn't have any gates. The example here is on the Owen Canal, where we've put in a new set of steel frame gates using tropical hardwood head and heels, but the heel here is actually steel. So it's been redesigned so that element is unaffected, isn't taking any load through the timber elements. The timber elements are literally just there for seals. And this is an FRP example. There is one of those now in the UK. The Environment Agency have put one on, a set in on one of their dry docks near Sunbury. So there is a set now in the UK that we can look at and see how that performs. And things we're trying to improve. So for example, here, this is where we've put steel rather than timber heel in. It allows us to more easily replace the collars, and also they're lubricated, and there's a self-lubricating liner between the two. And we've also been looking, can we standardize the components below water level? So examples of some different pins and pots on the bottom of the gates. They vary dramatically depending on where you are. And even to the extent that different fitters put this sort of design of pot in differently. So some will put this in closest to the gate, others will put it the other way around. It was designed to go so the heel or the wall of the canal is here, all of the lock is here, so that as the pressure comes off the gate, the pin in the bottom of the gate drops away and makes it easier to operate, but it makes it more difficult to fit. So as I say, trying to refine this and use some sort of standard components would make the design of the gates much easier. And having a standard element, so we design it for a maximum width and height, and you could have a standard component that you could then use. And in terms of design and fabrication, that makes things a lot easier, a lot quicker, and starts to bring down costs, but trying to again have appearance of a typical lock gate. So sorry, I've rushed through that because I'm just conscious of time. If I stop sharing, if there are any questions, happy to answer.
That's great. Thanks for that. It must just be me that doesn't understand the difference between leaves and gates, because nobody's asked the question. But as you tried to explain it to me before we started this session, and I obviously still don't understand, perhaps it's just me. But don't worry. just a couple of quick questions. One from Anne saying tunnel maintenance. How often are they thoroughly inspected and how is it done? I see that there are currently 10 tunnels on the high risk list. Should boaters be worried about using them? Now that's a simple one.
Yeah, those tunnels are inspected by our length inspectors as part of their length inspection process. So if there's a towpath, they'll do them every 2 months. If there's not a towpath, we try and do them every 4 months. We take the opportunity of boats passing through to undertake those, and they are also inspected by our tunnels team on again on a risk basis. So if they're in poorer condition, they're inspected more frequently, and that's a detailed inspection from a boat with typically a tower scaffold on, and when they come up, typically they're covered in brick rubble where they've been knocking around and if anyone is a keen viewer of Countryfile a few years ago, we had Matt Baker in Blisworth Tunnel going through on an inspection with one of the tunnel team, just seeing how that was done. And if we've got any concerns at any time, we have called additional inspections for tunnels. We get the guys out again on a boat so we can go through there and actually have a proper look and get up and touch and feel what's going on.
So what you're saying is full confidence, absolutely no problems going through tunnels.
No, quite a lot of concerns with tunnels. Some of them are to do with the actual lining materials, but a lot of the concerns, for instance, in Islington, which is one of those tunnels, is to do with movement on the portals. So it's around on the approach to the tunnel rather than the tunnel itself, and also sometimes, quite often, erosion at water level. So it's elements that are of concern but aren't necessarily in terms of the erosion at water level. They're less structural because the multiple layers of skin on the brickwork in the tunnel.
Great. One which I think you'll easily be able to answer this one. How much is maintaining heritage on the lock gates costing us? Just a ballpark figure.
Well, it doesn't at the moment because we replace everything like for like. So in terms of heritage for a gate, currently when we put a timber gate back in, we'll put a gate in that matches what's already there. And we will continue to do that. I think the innovation opportunities on the ones that aren't listed, and by increasing the life of those gates, creates more time in the winter to do works because we're not going back as often.
Just a final one, which is mine, that I've raised in several meetings, and I'm sure you've been at them online, is the rubbing strip on lock gates, especially the double locks. I'm just thinking of Batchworth lock, which actually empties in about 40 minutes because it's been worn away. Is there nothing that has ever been designed that can expand and contract to keep water in? Because and I'm guessing from what Adam said that it's not a particular problem or water loss on the Grand Union South because it's a lot of it's river fed, but almost every single lock leaks like a sieve on the Grand Union South. Normally that's not a huge problem, but it can be a problem, especially at Denham before it was the gates or leaves, whichever ones they are, were mended. It was almost impossible if you had one person trying to open the top gates. So in the end, you used your boat to help, which is not good, but that was the only way of doing it. So nobody's come up with any solution that works.
We've tried all sorts of things over the years. I mean, part of the problem is on wide locks with single boats, in that if you open a single gate, you get the rub at water level on the gate, which then creates an opening, which creates leakage. So what we tend to do is when they come new, we fit them with no liners, so without a strip insert. What we then do is, 10 years, 15 years down the line, we'll rebate and put a timber inlay into that. Now, the trouble is, the reason we don't do that from new is because you've got a piece of timber projecting from the edge, which is susceptible to get caught and pulled out. Or we tried rubbers, we tried MDPE, we tried all sorts of different things to line them with. There are some measures in terms of putting steel inlays on the upstream side of the gates, which effectively project beyond the mitre. Of course, that causes damage to boats, and
Good
not
if you're
all
a boat
boats are very,
painter.
yeah. And you know, if you've not got a steel hull boat, you're not going to want to go too close to that. So it is something we're looking at as part of the process. You know, do we use different materials? Hardwoods, obviously, tropical hardwoods last longer. So could we segmentally put the liners in, so we do say half metre above and a metre, half metre below and a metre above water level as a separate piece, so we can replace that more easily. But we've not found a material yet that can take the abrasion and also sort of fill the void.
That's answered my question, and I warn you, I shall ask it at every meeting that I go to and someone's talking about that. Anyway, thank you, Neil. Thank you, Adam. Sorry we've overrun a little bit, 13 minutes, so I'll keep going for another minute because otherwise it will be really unlucky. Just to say that we've got a webinar coming up on the 24th of November, which is the grandly titled The Future of London's Waterways. This is following the Canal and River Trust consultation about mooring in London, which closed in April and seems to have, I won't say been forgotten about, but nothing's come out about it. And the ever-present Matthew Simmons is coming along to say something about it. What it will be, I don't know. So that again is at 7:30, probably of interest to people that are outside London, given that most people I speak to went out on the waterway say, no, we don't go to London because it's too busy. It's not. So, and if anyone's got any ideas of future webinars, we're trying to sort of do some in-person and some online ones, because I think I think it's been really interesting today, and hopefully other people that have come along have learned a lot, and not just Canal and River Trust propaganda, but a little bit of reality about exactly what goes on. So thank you, gentlemen, and I wish everyone a good evening. Thank you.